solve another rational equation. Another one involving distance, rate, and time. Speeds. Go ahead and read that problem. Okay, so we've read it. Maybe we read it again. This one's a little bit different. This one, the last problem that we did that was like this, the two people traveled wherever they were going in the same amount of time. In this one, Bob's going to travel an additional 2 hours. So we're going to have to be careful right here. I still don't want to use two letters though. So let's talk about their rates. Fred and Bob's motorboat travels at the same speed, but it didn't tell me what the speed was. So I'm tending to fill in these first two columns, so I'm going to put X's in there. Fred pilots his boat 40 kilometers. 40 kilometers before he docks it. Bob continues for another 2 hours, but let's hold that information for a minute because we're going to make these into fractions, and we're going to talk about how they add or subtract to equal those 2 hours. But Bob's going to continue for another 2 hours, and he's going to travel 100 kilometers. So, you know, in the last problem, we wrote time as the distance divided by the rate. And these are pretty easy fractions right here. But these two are not equal to one another anymore. What we know is that this one's longer. He travels for a longer period of time, and this one's a shorter period of time. By what amount? What's the difference? How much longer does Bob travel? 2 hours. So, you know, let's just make up some numbers. Let's say Bob travels for 5, then Fred's going to have to travel for 3 in order for Bob to travel 2 more hours. Or say Bob travels for 11, then Fred must have traveled for 9 in order for Bob to have traveled 2 extra hours. So this was Bob, and this was Fred. Bob's time was 2 more than Fred. So all I'm going to ask of us is to take Bob's expression, the 100 over x, which represents his time, and subtract Fred's time, which is 40 over x, and set that equal to the 2 hours. Again, that's just to help you feel the problem. And then let's now solve this thing with the least common denominator being x. When I multiply this by x, and this by x, and that by x, on the left-hand side, the x's cancel out. So you're left with 100 minus 40 equals 2x. Make that a little darker. And so we have 60 equals 2x. And finally, x equals 30. Gosh, what's x again? X is the rate of their boats. 30. Let's read the last sentence. That's usually where the question is. How long did it take Fred to navigate the 40 kilometers? Not what was his speed, but how long did it take him to navigate? This is Fred's time right here. We know his rate was 30. And so now we can figure out Fred's time by saying the time for Fred is found by taking 40 minus the 30, or let's reduce that to 4/3, and let's call that 1 1/3 hours. You know, if I wanted to know Bob's time, I would just go ahead and say that Bob is 100 divided by 30, and reduce that, that's 10/3, or 3 1/3 hours. So that's a kind of a nice check to see that Bob did take 2 hours more. We could also take those, if you will, rate times times and check them and see if they equal 40 and see if they equal 100 is another check. So this one's a little bit harder because their difference in time was 2 hours. Their difference in time was 2 hours. You just have to make sure you put the bigger number for time, the person who goes for a longer period of time, minus the shorter period of time to equal that 2 hours. Very good. There's still some more applications of rational equations. I mean, there are proportions. They're real easy problems. We can go ahead and take a look at those next.